Let's get started. Sorry about the delay. I know this is a BoF, but we ended up having a few slides just to give an outline of the things that we've been working on for Upstream. So these slides are slightly updated from the last BoF we had in San Francisco based on the progress we've done. But if something is missing and needs to be discussed, please feel free to bring it up. These are the areas we'll try and cover today. There are about maybe more than 10, so we'll probably have 5 minutes each to talk about each of them. Starting with baseport, I think Bjorn will have more to add, but I guess we have SSR now based on remote proc. The core patches are still ongoing, and QMI RMTFS is already merged. There are a bunch of things on 845, which is the new SoC after the 89, 96, and 98. Modem pill, LLCC is the new system cache driver, and the ARM EDAC support. As well as the RPMH and PDC interrupts. For still to do, there's process domain restart, which is a new thing, and then some in-kernel pill drivers for ADSP and video. Yeah. So, Bjorn, you have something to add for?
For PDC? No, I think the PDC is good. So what it is it's an always-on interrupt controller living while we're turning off the GIC. And I think that the reviews have gone good on that. The PDR, no, we haven't made any good progress there yet. So that needs investigation. The pill stuff, it's downhill from here, it will land. SOC info, yeah, that's been on the main list. I rewrote that a while ago because I needed a serial number, so I should be able to post that. We got RPMH regulators posted last week, and the RPMH discussion is ongoing. So essentially, they've taken the old RPM and shoved it into hardware, so it's better. But so all those things are ongoing. The two items that I saw that needs to happen rather soon is the QMP, which is a messaging protocol to override the hardware when it's when to set like minimum regulator voltages for heating purposes. Not cooling purposes, but heating purposes. And the other one that is in generic stuff is there's several or many people who have complained that the downstream logging framework for everything related to coprocessors isn't available upstream. And I've said that a generic let's log everything in a Qualcomm specific framework is not going to fly. So that's that needs some attention.
Could that be done with the ftrace framework, with tracing?
The majority of it.
Okay.
So the part that we don't have a good way of is they want trace of the communication between the coprocessors as well. So essentially data logging in RP message, which is one of my open to do items. So yeah. So someone probably needs to write that and then document how do we do trace points and how do we use that to meet the same requirement set. You had one more baseport item. Okay, good.
So moving on the memory side, I think the SMMU runtime PM patches will make it finally. They've been on the list for more than a year now. There's been more work going on Ion, but I'm not sure if we have anybody here who has more details on the Ion work that's happening. Brian, you had anything on the future SoCs? Still to do, there are a few things for I think for IPA, we need a fast map on map. Fault handler, I think it's still, Rob posted some patches for those. And then there's a bunch of errata and optimizations in the downstream SMMU drivers, which needs to be upstreamed. Context bank handoffs is something new with 845 that's done downstream. I'm not sure if that's really needed. I was talking with Rob in the morning. Unless the bootloaders plan to use SMMU to for the boot splash screen, that is.
I mean, there is more than just context bank handover, but how does the kernel find the scan-out frame buffer if, like right now, we describe it as a base address and a size, not like a scatter list of pages. Plus, why is finding contiguous memory a problem for the bootloader?
Yeah, I'm not sure why we are doing it this way, but that's what we saw was done on the Android bootloaders.
Yeah.
Vivek, do you know why?
Yeah, I think that's the design side requirements that come from downstream to start using SMMU. Although they are making one-to-one mappings for at the bootloader level for the splash screen buffer, but yeah, just when the kernel would start coming up, we needed context bank handoff in order to handle it.
So if it's one-to-one, then it means that it's not because they don't have contiguous memory at the bootloader, right?
Yeah, that's not the reason. Yeah.
So we probably still need to figure what's the reason why this is done.
So, I mean, on earlier things, it's kind of using the IOMU, but in bypass mode. So does that not work anymore, or?
I'm not really sure. They're not using in bypass mode, at least. They are still setting up the context bank for display. Yeah, it's not in bypass mode.
Yeah, I mean, I guess we probably have to follow up on there and find out what's really needed.
I would guess it's just done for protection purposes, so it doesn't access any of the other memory that's not the frame buffer.
Yeah, could be, but.
Yeah, it's just guessing.
There are a bunch of peripherals which are using SMMU in the current design 845. You have UFI using a bunch of them. So I think that's one of the reasons, protection is one of the reasons probably because of which you have SMMU set up for the display context banks. Yeah, I can follow up on that and
A lot of things on power management. So we have CPU Freak for 8996 ongoing. I think that still does voltage scaling using SPMI and the clock driver for the CPU clocks. And then A53 CPU clock driver has been going on for a long time. I'm not sure if it's merged. Sure,
It's upstream.
Okay. A bunch of clock drivers for the new SoC 845. SPMI PMX stuff is merged. And then the boot constraints part. So this is something that Viresh has been working on to come up with a generic boot constraint framework. And I think we got some work done on 410C to get it working but we still need to see if it can be used on 820, which is probably what we'll do this week. Talk to Viresh, but I think the boot constraint framework itself is not ready for merge yet. It still probably has some open things based on Rob's last feedback. So the RPM power domain is for the voltage corners. So this is another thing that that the power management working group has been working on for supporting performance states for the power domains. So that's so there's a power domain modeled corner modeled as power domain for 820. We probably need to do the same for 845 as well going forward. But the big thing missing there is still the multiple power domain per device support. Bus scaling is ongoing work over the last couple of years. We have some prototype working on 410C. We need to extend that to 820 and to 845 going forward. And then PM domain patches, I think Lina was working on this, and then I saw Ulf picked it up and posted some patches a couple of weeks back. CPR is still work to do. That's the AVS thing found in Qualcomm socks. OSM-based CPU freak. OSM is a new IP in the new SOC, which does a lot of TCBS and hardware. So you can program a SOC-specific sequence and some sort of OPP tables in the SRAM, and then you just program the index into a register, and the OSM is able to do the CPU DCBS. So that kind of brings down a lot of complexity from the software. Bus DDR scaling is something which built on top of the bus scaling things that Georgie is working on. And then RPMH regulators, I think Bjorn talked about those being posted. So there are two kinds of those, one where we directly control based on the voltages, and then the other ones are the corners. So the corner ones, we still need to do it based on the performance state for power domains. Sleep set support is another thing which is still missing. Need to work on that. Amit, you add anything more to add? Okay. Okay, thermal, you want to talk?
All right. So we've been working on getting improvements to the thermal framework. First one being having the possibility of multiple sensors in a single thermal zone. And then there's also a requirement of a sensor spanning thermal zones. So I've talked to Eduardo a bit, and with Lina from Qualcomm, we have the patches somewhat ready to post in the coming weeks. The downstream tree also has this thing called the heating governor. So he alluded to the thing where you need to keep regulators on. I like to call it the Finland governor. So there's basically, if you're in negative 20 degrees, negative 30 degrees, to ensure timing closures in the circuit, you need to make sure that you keep some regulators on and keep a minimum temperature. So what they've done in downstream is introduce a new governor. I'm trying to change that to where the thermal governors accept a range. So there's a low and a high value instead of introducing a new governor. So still prototyping that bit. As far as still to do, yeah. So the regulator cooling device is just registering a new way to shut down regulators in some cases. Core isolation, again, exists in the downstream as a separate patch set, but I feel that what Daniel Lascano has posted with the idle cooling device might satisfy that. So we need to test that out. And maybe we don't need core isolation anymore. And then there's some SoC-specific drivers that we need to get upstream, some regulator stuff, and interrupt support for T-Sense. That's still pending.
Is the framework supporting that now? The thermal framework supports?
Yes, it does.
ACUs, okay.
So it's something I started looking at, and I'm now in touch with the team inside Qualcomm that's in charge of that.
Right.
So
Yeah. Back when we upstreamed the T-Sense support, the IRQ support was missing in the thermal framework itself. It supported only.
So yeah, I mean the polling and then moving to interrupt based.
Yeah.
So it's possible now. So
Okay. I think Vansa had some. Thing.
For the I key, the thermal sensor is using interruption now.
I think that's it from Tamil.
On the peripherals, I think UFS is unfortunately broken for a while due to DevFreak changes.
Yeah, so they abused the DevFreak API, and then the DevFreak guys fixed that, and UFS broke.
So this is the UFS core.
Yes, it's a UFS host core driver that's broken. With that fixed, there is still a 50% failure rate on A20. So the lane clocks comes from the PHY, but 50% of the time, the timing gets to a point where, or rather, the PHY initialization ends somewhat later, typically because of probe defer from the regulators, and that causes the lane clock not to turn on. And I've done some debugging and talked to Vivek about it, and yeah, we need to figure out what that is, and we don't know if we will have that on, for example, 845 as well, or if it's something specific to 820. Or
Right, yeah. I think the 845 support patches haven't started flowing in yet.
no, I haven't seen anything there, but
USB and I think SDHC and USB are good. We have the device mode support was missing for USB 3. That's some of those patches are out now. Those were, I think, tested on 845, but they should work on 8996 as well. So.
but we need a new PHY driver for those as well.
For
USB.
The PHY drivers are already merged, I think. Yeah.
Okay, good.
So just picking these patches will make device mode work on 89 on the 820C.
Yeah, on 820 it works, but 845 needs a new PHY.
Yes, and the 845 new PHY drivers are also out.
Okay, good.
Yeah. Jenny is the new serial engine IP and the new SoC, which can be used to program each serial interface as either UART, I2C, or SPI. The drivers for these are also on the list. They're under discussion. PCIe, I'm not sure if there's anything pending. Are we?
You say we're good.
You say GD drivers on the list?
Yeah. I think SPI is still missing, but UART and I2C is. Yeah.
That's why I haven't seen it.
Yeah. PCIe, nothing? Nothing is, okay.
Are we good with the power domain as well?
Yeah.
For the AGNOC?
Wow, that's critical. So Stephen took it. Scary.
Yeah, display GPU, I'll probably hand over to Rob. You,
So yeah, a few weeks back we got a massive patch for the driver for the new display controller in 845, which also included a duplicate DSI subdriver and lots of other things. That's being scaled back, so they're moving back over to the original DSI subdriver, which is already upstream and is already used on 410 and 820 and so on, cutting out a lot of stuff. The existing code also includes user space API for a lot of things we don't have an open source user space for, so the plan is basically hacking a lot of that stuff out and then reintroducing that later. That's mostly being driven by Sean Paul from the Chrome OS team. Yeah.
Yeah, so this patch posting was kind of intentional. This is our kind of downstream driver, kind of as is, and it's full glory, kind of brought up to mainline and posted as RFC so that we could get a lot of valuable feedback on it. The intent was not that this is ready for prime time at all, but really to get some meaningful feedback on what needs to be done on display for this hardware.
Yeah, I know about that. I guess I should have pointed that out, but yeah.
Yeah,
it was
it's
a
good to see it
starting
going.
point, not the it's ready to merge.
GPU, I think A6X RFC is out, and then there's this new GMU thing coming in with 845, which is an external microcontroller to do the power management for the GPU. So I think those patches are out from Jordan. There's some patches for preemption support for the ring buffers as well. And then some debug enhancement patches for GPU.
Yeah, so preemption support's merged already. A6 and GMU stuff. I had a quick look. It looked reasonable. I mean, it's not going to land upstream until until I have a chance to make a user space. The GPU crash dump stuff looked reasonable. Maybe we can get that in for 418. On the still to do, I'm not sure if the critical packet stuff's actually needed. I think the version of the 8996 that we have in 820 is new enough not to need that. Unless it comes back in 845 or something. It's simpler if we don't need it. Per process page tables, I haven't been following that as closely, but that's, Jordan's been watching the ARM SMMU SVM discussions. That seems to be part of a dependency for that. And we should have the clock scaling stuff. We did at least move over to the DevFreak bindings for that. I need to double check on that.
Okay. Moving over to video, I think this slide is basically from the last BoF. I haven't updated anything much on this. But I think Stan's been working on adding support for 845 video using the same driver as we have Upstream, which supports both 8916 and 8996. The only other thing which comes up newly with 845 is the SMMU integration, which want to talk about it?
The non-secure pill part also
Yeah,
comes.
yeah.
Until 1896, you had TZ programming, the context banks for the firmware. Now all that is moving into the kernel, so you have to use the firmware's SID. So yeah, the current bindings are like you have a decoder and an encoder, each having its own SID. Yeah, you have to handle the firmware's SID as well. And yeah, that's something that we want to discuss, since the firmware is not exactly a hardware entity that you can represent in a device tree, but you need to have a separate device, struct device, for it to have its own context bank and mapping. So yeah, we need to consider how can we actually represent the firmware context banks, and since it has its own mapping requirements, the firmware actually starts executing at 0x0, and you load the firmware into a particular physical memory, reserved mem, and you need to create that mapping.
So since it's an ARM core, I think the firmware needs to execute from the 0x0, so it needs some custom IOVA mappings to be done. And that was done earlier by the bootloaders, and now it needs to be done from the kernel driver. So I think the way we've gotten it working right now is to put firmware as a child node, like a child node in the BitC node, but that doesn't look very good from the DT bindings point of view.
Yeah, that did vaguely related to remind me of a problem we do have on the GPU or on the DRM driver side of things. We need the DMA mapping API registering its own domain gets in the way, or is on some systems gets in the way of the per process page table banks, because it ends up but we need a way to basically trigger unregistering that domain that DMA mapping registers.
Yes, that has been an unsolved problem for a while. I think NVIDIA was the first to run into that, and they also don't have a solution yet. So that needs to be discussed more globally.
In my case, we're never going to use the DMA mapping registered domain, so just an API to say, please get out of that we can call to say, please get out of the way for this device would be fine. I don't know what other people's requirements are, but.
I don't remember. I think at some point NVIDIA didn't actually register the devices by default with the default domain at all, so they're only allowed using their MMU interfaces to get a domain. Otherwise, it wouldn't use the MMU. We shouldn't be that inconsistent between platforms.
Yeah, plus we also need to use the same ARM SMMU IOMU driver that other devices and other SOCs are using. So.
The other problem that I've seen a few times with the way to load firmware into devices on the Qualcomm chips is apparently that the firmware interface is not particularly well defined to what kind of addresses it takes.
It is well defined. It's just more convenient to use the DMA alloc. So it takes a physical pointer.
I thought there was now a case where it doesn't, where it takes a DMA address that might be an IMU.
No, it takes a physical address, the SCM interface. The problem we have is that, so how do we allocate the chunk of physical memory? So, and the DMA alloc happens to do exactly the right thing because the DMA address and the physical address is the same, except for a few cases.
And those are the interesting ones.
Yeah. So the cases where that can argue is not whether they are not the same, those we have worked around now. The one case where that's left is the Qualcomm SEM driver. Where we know that it works because if it doesn't, then the board won't boot at all. But yeah, it's wrong. The question is we don't know what to do about it. For a while downstream, it was KC alloc. Then, according to the Git log, they ran into speculative access. So something hitting that while TC was executing on that memory or utilizing that chunk of memory, and therefore the entire system was shut down. So essentially what we want is a KC alloc that can be large in some cases and can be locked out of Linux for the time while we're executing in trust zone. And allocating DMA coherent memory is close to that.
Yes, I understand. I thought, did I talk to you about that? I thought there was one more requirement that came up now, that we actually have to pass something into firmware interfaces where that will be accessed by a device through a DMA address that might be an IMU, after all, which we originally said would never happen.
I don't think it was me you discussed that way, but yeah.
There is an outstanding discussion on the list about this very case. And so I deferred it until now, where we're having this discussion.
Can't we just defer it a little bit longer?
I don't have to send, a pull request for this.
So in the remote proc drivers, I have an extension to this problem that, so right now I'm memory mapping RAM, copying the firmware in there, and then we jump to trust zone, and it's that will kick off the coprocessor executing that firmware. And we're just leaving it like that. If for some reason, for some of this code processor, the app CPU would touch that memory, we get the system restart. So I'm contemplating just adding a just unmapping that memory for the duration while we're running, except that the code. It will still be linear. Okay, yeah, and the code looks crap. When I do that, especially in the fault handling, because I end up unmapping a couple of times, I don't know how to solve that either in a sane way. But for the SCM, it would be nice if we can get a chunk of physical RAM, map it for a while, unmap it, call trust zone, and when we get back, map it again, and I think that would be the optimal.
Yes. So one idea that I had earlier was to basically do the same as the DMA mapping in implementation and base something else on top of the underlying allocators. But then you're absolutely right that this is essentially coming to the same code that we already have there.
Yeah, and in the remote proc case, we also have the problem that so traditionally we used the DMA alloc. However, it used the bitmap allocator, which allocates, you don't specify the size in bytes, you specify an order. And conveniently, one of our firmwares is 34 megabytes in size, so we would waste quite a bit of RAM by doing that. So, yeah. So I agree, Arne, that we need to fix it, but I don't know what to do about it.
Okay, moving on to networking data. I think RMNet is mostly merged now. Okay.
Yeah, ARMNet is there,
Yeah, RMNet
but
is.
there's no users.
Right, yeah, yeah. And
So that's a network interface. And the backing or implementation of RMNet can be, it was in the past some sort of shared memory, but what we have on anything modern is the IP accelerator block.
yeah, and then the IPA work is in
Yeah,
progress.
so I can talk a little bit about that. I actually updated the slide, but you didn't get it
Oh,
apparently.
okay, sorry.
So I've been working on the IPA code. I started with the downstream code, and I've been refactoring it for a few months. And it's still a large driver. It's a complex device. It started at something like 38,000 lines of code, and I've got it down to about 24. But that's just lines of code. I think the improvements are more than just the lines of code reduction. I've been doing some other things along the way as well. So I've got it reduced that far. The next steps are to, well, the goal is to get it into upstream. At the moment, I've been working up until now in the downstream environment, and so right now I'm in the midst of bringing it into an upstream environment. The challenges there are that there is a little bit of a user space component that is not as well defined as I'd like to be, or at least not to me. And so I need to find out what exactly is required from user space for configuring this. And then there are a couple other kernel interfaces that are different between upstream and downstream, SMMU and QMI, and a couple other things that I've just got to kind of work out the kinks. But so then once that is integrated and I can verify it, then the next step is to figure out how to get it reviewed upstream.
And on the way here, we found one more networking item that we should touch upon, and that's Wi-Fi, which is some variant of the HKG18-213 driver with a new control interface. But I think that's ongoing inside Qualcomm.
Yeah, for the 845, yes, yeah.
So on IPA, is it correct to say you plan to post a V1 of it and not an RFC?
That's what I'd like to do. And a third option is to maybe post it and just stuff it into staging and continue working on it, but I don't really want to do that either. So I'd like to post it as a V1, but I'm sort of in the midst of conversations this week and trying to figure out who I need to talk to help shape the strategy for that.
So the two things that you mentioned, two other things that you mentioned, the SMMU support and the user space support, those sound to me like things that the driver should not have in an initial version.
Okay, down to audio. I think Srini has been working on the ADSP-based audio for a while now.
Yeah, so I posted before patch set a few weeks back with Mark's comments addressed. So far what we have in that patch set is basic playback and record support on multiple interfaces like I2S, HDMI, Slim Bus, and it supports multiple SOCs as well. It's been tested on SDM 845, 8996 and 8916 and 8974. I've been working on a feature where ADSP versioning support is also included in the patch set, so that it can dynamically determine which ADSP firmware it's working. It is, and then it can change different commands based on that. Yeah, and there's big items to do is some of the codecs which are based off Slimbus, which depend on Slimbus channel and port support, which we are planning to send patches maybe in next few weeks. That should at least get most of the analog and digital audio working on top of mainline.
And the Slimbus framework is merged now.
Yeah, the basic framework is in there, but yeah, you need channel and port support to get the codecs.
I think we're on our last slide. Camera, Tudor, you want?
So the so-called camera subsystem driver, which controls the CSI receiver and the VFE, we have that one, the version which supports 89.16 merged in kernel 4.14. So currently I'm working on the same support for 89.96. So mostly the same features are already done. This includes the road dump to memory, and for YOV frame format we have support for format conversion and then scaling and cropping. So the one thing which is still to do is the support of the second VFU on that, which also depends on the multiple power domains per device functionality, whether we will have this. So this is something which I hope to understand more about this week. And after the second VFE support is done, I will post the patches upstream. The other thing about the camera is the driver for the camera control interface. So I have posted already a version which supports both 89.16 and 89.96. The next thing to do will be to support the second CCI bus on 89.96. So the next version of the driver will add this, and I'll continue with this.
And I took the liberty of adding the last line to your slide. So for all the use cases we have discussed so far, CCI is just an I2C bus. And then when I was reading the hardware documentation, it seems like, so there is two I2C masters, and then there is a GPIO driver engine thingy where you can configure GPIO interactions to be either run independently or synchronized with I2C operations. So we probably need to maybe talk to Linus and Wolfram about how to cross-pollinate or something to be able to do, so that would be used to, so you can invoke a set of I2C operations on your sensor and then trigger a strobe light over GPIO and then do some more I2C and so on. So,
well, there are even more functionalities by the CCI, because you can synchronize the CCI commands and the GPIO with the frame start and end.
Right, you can wait.
So it goes a lot beyond the I2C driver. But this is something which I don't know how we can. This is something new.
Yeah. Yes, Wolfram didn't show up for some reason. Maybe we can attack Linus.
Okay.
All right, I think that was, yeah, this is the last slide we had. So, yeah, thank you everyone for the participation.
I have a question. We had for a while people from Code Aurora submitting command queue support for MMC. Are these new boards all using UFS, so you don't care? Or what were these people using that was, they disappeared? So they sent some patches, and then Intel finalized the work, and now it's upstream. But there is needed host support for the MMCI derivative that Qualcomm is sometimes using.
Okay.
If you
So
want this.
how long back was this posted?
Maybe you know.
But for MMCI, that's years ago. So there's probably not a Qualcomm engineer. I've worked on that for years.
I think that was for designware or something like that. So it's like somebody put in a new MMC controller. Sorry for the MMCI blathers, wrong. So for the new MMC controller that's in Qualcomm hardware, somebody was working on command queuing, which is an extension in MMC 4.5, I think, or 5. And Intel have it working now. So we only have driver for that SDHC derivative that they have. But there were people from Code Aurora, and I can look it up if you're interested, and you can look at it. But it's on the floor right now.
Okay. Any more questions?
I have a little bit of high-level question, because all the chips that we were talking about are always like the same 5 or 6 chips out of maybe 20, 30 widely used chips. How did you come up with the specific selection? Is it always just the latest high-end model and the 410 because that's widely used, or is there a method to this, or is it just whatever people have to be working on?
Yeah, so how do we determine our roadmap? So the primary focus thus far has been on publicly accessible platforms, which for us is the Dragon board built around the 96 board spec. And quite frankly, there's so many things to do that even older chips, getting a lot of the work done there has a lot of value for us going forward on new chips. And so that's why historically you've seen the focus on getting these chips fully functional. And it's not just an upstream focus for us, though. There's an intent to have long life products, long-term availability products built around Dragon board, and so the intent is for those to be around for a long time as well. And so those chips are important for that focus. With some of the newer work around 845, there's not a Dragon board focused around that. It's our current generation chip, and so the intent is to solve some of the problems there that the Dragon boards don't have yet. And so the landing team, because of our relationship with Linaro, they have access to that hardware, and we're able to do more work in some of the newer chips now. Hopefully this time next year we'll be talking about, something beyond 845 as well, and bringing that up to comparable levels of support. So we hope to expand the number of chips supported going forward. Any more questions?
Okay, thank you everyone. Thanks for your participation.